All right, so now we are 100 seconds after the Big Bang. The temperature is now down to 3 billion Kelvin from 6 billion Kelvin, and the size of the universe has increased to 10 to the 46th meters across. So what has happened now? So let's take a look at what we started with up here and compare that to down below. And so you'll notice I added a new symbol, and that's going to be the neutrino. And so what's going to happen during this time period is neutrinos are no longer going to interact with matter. So let's talk about what a neutrino is and what they do. So we've already talked about neutrinos before. So neutrinos, and that's given by this symbol here that kind of looks like a bird, and are made when a neutron changes into a proton. So you've got the neutron turns into a proton, and then also an electron is given off and a neutrino. Or they can be made when protons change into neutrons, as in what happened during a supernova. So if you recall, we said that when you manufacture iron nucleuses, that was really bad inside of a star, because then there'd be no longer any nuclear explosions keeping gravity at bay, and the star collapses, and then it has one last card to play, and it changed its protons into neutrons, and then that's what generates this supernova explosion. And then you're left with a neutron star, the thing that's left over. So notice that when a proton combines with an electron, it will turn into a neutron and a neutrino. So these are particles that are given off when protons change into neutrons or neutrons change into protons. Normally, the neutrons just escape, and the neutron has no electrical charge, so it will not interact with anything that has an electrical charge. And it's a very, very small particle. So once this neutrino is released, it basically just escapes our solar system and heads off into interstellar space. It takes like 1 million miles of solid lead in order to be able to stop a neutrino. So they just basically do not like to interact with anything. But under conditions of very high density and energy, neutrinos do interact with matter to remake protons and neutrons. So prior to this point in history, so prior to 100 seconds after the Big Bang, the neutrinos were interacting with matter. But now the universe has expanded so much that the neutrinos can escape, and so they no longer interact with matter at this point. Now, if you are one of my students, don't worry about anything that I just said. Okay, not going to be on the exam, but your textbook does talk about it, so I wanted to mention this thing about the neutrino stuff. All right, so let's keep going. Now we are 3 minutes after the Big Bang. The temperature of the universe is down to 1 billion Kelvin, and the size of the universe is up to 10 to the 46th meters across. And let's compare what the universe consisted of. So it's going to be protons and neutrons and leptons and neutrinos. But what do we notice now? Notice that there are nucleuses, so that the protons and the neutrons are combining into helium nucleuses. Nuclear fusion. So that, what did we say was the temperature necessary in order to change protons into helium through the pp chain? It was 10 million Kelvin. Is 1 billion Kelvin bigger than 10 million? Yes. So the protons start to slam into each other and they start to manufacture helium nucleuses. However, and also just a little bit of lithium forms. So that once you make your helium, it starts to smash into protons and turns into lithium. But that's about it. But if you look at this temperature, you might think that you should be able to manufacture even heavier elements with the temperature this high. But you don't. Okay? So the entire universe now was still hotter than the center of a hypergiant. Hydrogen fused into helium, and helium fused into just a little bit of lithium. But the heavier elements did not fuse because the temperature of the universe was dropping so quickly. So notice that by the time that we get to out to here, the temperature has now dropped to 3,000 Kelvin. So the temperature of the universe has decreased so much that you can't fuse heavier elements. So that's why today, if you look at the composition of the universe, it is going to consist of roughly 75% hydrogen, and then it's going to be about 24% helium, and then it's going to be about 1% everything else, and of that everything else, most of it is lithium. So these are the three main elements in the universe today, and they came from this time period of 3 minutes after the Big Bang. Okay, now we are going to take another break. So when we come back, we're going to talk about the origin of light.